Unit 1 Laser. So what is laser? The laser is acronym for light amplification by stimulated emission of radiation. So the laser stands for, it is acronym LASER, stands for light amplification by stimulated emission of radiation. So to better understand laser, so first of all let us try to understand what is radiation, followed by what is stimulated emission and how the stimulated emission is going to amplify light. So let us have a look at radiation. So in the case of lasers, we are talking about atomic radiation. So all of you know that what an atom contains. Atom contains nucleus. Around the nucleus we have several orbitals. And the orbital which is very close to the nucleus is called as ground state, or even we can call it as lower energy state or stable state. And whereas this other orbital is called as excited state, higher energy state, unstable state, or valency state. For our convenience, let us represent these orbitals as straight lines, and this is our lower energy ground with energy E1. This is higher energy E2. And lower energy state is the most stable state, so that's why the electrons will reside in the ground state initially. Now let us talk about absorption before we are going to talk about spontaneous and stimulated emissions. So this is our excited state E2, this is our ground state E1. Initially the electrons are in the ground state. As there is no energy supply, these electrons are not able to move from lower state to higher state. So to make them to move from lower state to higher state, we have to supply external energy. So if we provide external energy, the electrons will absorb that energy and they will lift from lower state to higher state. So this mechanism we will call as absorption. So absorption can be defined as the electron in the ground state absorbs external energy and moves from lower energy state to higher energy state. This is known as absorption. And absorption phenomena depends on the nature of lower state as well as nature of higher state. Apart from this two, it also dependent on external energy supply. So what we can say is absorption depends on external energy. But you know, higher energy state is quite unstable. So the higher energy state is unstable. The electron's lifetime in the higher state is 10 power minus 8 seconds. That means the electron cannot stay more than 10 power 8, more than 10 power minus 8 seconds in this state. So what should it do? It has to de-excite. It has to de-excite. So electron in the higher state is quite unstable. Its lifetime is only 10 power minus 8 seconds. So it has to de-excite from higher state to lower state. Higher state to lower state. So what does it mean? So is there any external energy we have given to make this electron to jump from higher state to lower state? No. How it is coming down from higher state to lower state? Spontaneously. Without any time delay. It cannot take more than 10 power minus 8 seconds. So it has to drop down from higher state to lower state. So the spontaneous emission. So the electron in the excited state is unstable and it cannot stay more than 10 power minus 8 seconds. So it has to drop down by releasing the absorbed energy. This mechanism is known as spontaneous emission. So here, while it is moving from lower state to higher state, it has taken an amount of h nu. The photon is absorbed. So the same amount of photon it is going to release when the electron is jumping from higher state to lower state. We can express this as E2 minus E1 is equal to h nu, or in fact nu is equal to E2 minus E1 by h, where h is constant. So the frequency of emitted light is dependent on energy gap E2 minus E1. But coming to the laser, we are looking for stimulated emission, and what we got here is spontaneous emission. So now let us look at stimulated emission. Stimulated emission. But stimulated emission to take place, the necessary condition is, apart from the ground and excited state, we must have another intermediate state. So this is E1, this is E2, this is E3, and this is known as metastable state. So what is the definition of metastable state? It is a state where the probability of finding the electron is more than excited state. So the lifetime of excited state is 10 power minus 8 seconds, but the electron reaching to the metastable state can stay for 10 power minus 3 seconds. So the metastable state can be defined as the state where the probability of finding the electron is more than excited state. For stimulated emission to take place, we must have metastable state. So initially electrons are in the ground states. When you supply energy, they will go to higher states, but higher state is unstable. They will return back to metastable state, or some of the electrons directly jump from higher state to ground state in a spontaneous method. So electron which reach to this metastable state will stay for 10 power minus 3 seconds. So this is our E1 ground state, E2 metastable state. The electron which reach to the metastable state will stay up to 10 power minus 3 seconds. During this stay, the photons emitted from spontaneous emission, if they are going to stimulate this electron is also going to jump from higher state to lower state by releasing another photon. In this case, we have stimulated photon. Apart from stimulated photon, because of the electron de-exciting from E2 to E1 state, we have another photon. And what happened here, you can observe very clearly, we have given one photon as input, we got two photons as output. That means what is happening here? By the mechanism of stimulated emission, we have given one photon as input and it is giving two photons. One photon becoming two photon is a amplification. By this stimulated emission process, we are going to amplify light. So, how can we define stimulated emission now? The electron in the metastable state, when stimulated by sufficient energetic photon, the electron de-excites or the electron drops from metastable state to ground state by releasing another photon. And here also you see how much stimulated emission takes place depends on how many photons are available for stimulation. So stimulated emission depends on external energy. So this stimulated emission we are going to use to create lasing action. So far we have discussed about what is laser and what is absorption. So prior to the spontaneous emission and stimulated emission, absorption must take place. So absorption is a process in which electrons in the lower state absorbs external energy and lifts their position from lower state to higher state. And coming to the spontaneous emission, the electron in the higher state is unstable. It cannot stay more than 10 power minus 8 seconds. So it has to drop down by releasing the absorbed energy. And spontaneous emission is independent of external energy. Independent of external energy. And coming to the third one, stimulated emission. For stimulated emission to take place, the requisite condition is we must have metastable state. So metastable state can be defined as the state where the probability of finding the electrons is more than excited state. So when the electron is in the metastable state, it wants to stay for longer time up to 10 power minus 3 seconds. During this, if any photon is going to stimulate that electron, the electron drops down by releasing another photon. Now before going to discuss the Einstein coefficients and their relations, let us distinguish between spontaneous emission and stimulated emission. What are the differences between spontaneous emission and stimulated emission? Number one, spontaneous emission takes place between excited state and ground state. Whereas stimulated emission takes place between metastable state and ground state. So here the lifetime of electrons involved in the spontaneous process is 10 power minus 8 seconds. Whereas in the case of stimulation, lifetime involved for the electrons is 10 power minus 3 seconds. Third one, spontaneous emission is incoherent. There is no relation between one photon and another photon that is coming in the spontaneous emission. But you can see the two photons maintaining the same phase and same amplitude. So what we can say is stimulated emission is coherent in nature. Right? So like that we can differentiate between spontaneous emission and stimulated emission. So it is incoherent, lifetime involved is 10 power minus 8 seconds. And what is the other important thing is independent of external energy, independent of external energy, whereas the stimulated emission is dependent on external energy. Right? So after understanding the differences between spontaneous and stimulated emission, now let us discuss about Einstein coefficients and their relations. Einstein's coefficients and their relation. Just now, in the beginning, we discussed absorption. So, what is absorption? Electrons in the ground state absorbs external energy and moves from lower energy state to higher energy state, and we call this as absorption. And we told that absorption depends on external energy. So, from this definition, so you see, this is first process is absorption, and already we defined absorption in the previous slides. So this is our ground state with energy E1. This is our excited state with energy E2. The electron is in the ground state and it is absorbing external energy, and after absorption the electron is jumping from lower state to higher state. The electron is jumping from lower state to higher state. So here what we can say is probability of electron jumping from lower state 1 to higher state 2. P12 stands for probability of electron jumping from lower energy state E1 to higher energy state E2, depends on the nature of E1, nature of E2. Apart from this, as we told earlier, absorption is dependent on external energy. So P12 is proportional to U of mu. This U of U known as energy density. What do you mean by energy density? Number of photons available per unit area. How many photons are available to make them to lift from lower state to higher state? That we will call as energy density. So P12 is proportional to U of mu. To remove this proportionality symbol, we are introducing a constant B12 is equal to B12 into U of mu. This is our equation 1, where this B12 is known as Einstein's coefficient of coefficient of absorption. Now after absorption, what is the other process we have discussed? It is spontaneous emission. Right? So before the process of spontaneous emission, where is the electron? Electron is in the ground state. And what is its lifetime? 10 power minus 8 seconds. So it cannot stay in the higher state because of instability, because of its lifetime. So electron has to de-exit from higher state to lower state by releasing the absorbed energy. But we are very clear that for making it to drop from higher state to lower state, there is no need of any external energy. So the probability of electron jumping from higher state to lower state by spontaneous is independent of external energy, but this process is equal to a constant A to 1. So this is our equation 2. So it is independent of external energy density, but this process is equivalent to a constant A to 1, where A to 1 is called Einstein's coefficient of spontaneous emission. Spontaneous emission. And coming to the third one, stimulated emission. Stimulated emission. So before the process, there is a electron in the metastable state where its lifetime is 10 power minus 3 seconds. When a photon is going to stimulate, the electron draws from higher state to lower state, and it releases a photon. So here we are getting two photons. One is the stimulated photon and other one is the emitted photon. So this is the stimulating photon. This black one is the emitted photon. So here also, what we can write? Probability of electron jumping from higher state 2 to lower state 1, E to 1, by stimulated mechanism is proportional to energy density. How many photons are there for stimulation? And to remove this proportionality symbol, P to 1 stimulated is equal to B to 1 U of mu. This is our equation 3, where B to 1 is Einstein's coefficient of stimulated emission. So from our three definitions, we got three equations. So one is P12 is equal to P12 is equal to B12 into U of mu. This is our equation 1. Second one is P21 is equal to P21 what process? Spontaneous is equal to A21. And the third one, P21 stimulated emission is equivalent to B21 into U of mu. So we answered the first part of our discussion. What are Einstein coefficients? So A21, B12, A21 and B21 are called Einstein coefficients. Now after understanding these three coefficients, next how are they related? Relation between Einstein's coefficients. So at equilibrium, if you consider two states, lower state and excited state, the number of electrons moving from lower state to higher state must be equivalent to the number of electrons coming from higher state to lower state. Suppose there are 10 electrons. All these 10 electrons are excited by which process? Absorption. As for our equilibrium condition, number of electrons moving from lower state to higher state is 10. Then certainly the number of electrons coming from higher state to lower state should be 10. But coming to this 10, all the 10 may not come by spontaneous method or stimulation method. There is a sharing between spontaneous and stimulated machines. But anyhow, the number of electrons moving from lower state to higher state must be equivalent to higher state to lower state. Let us assume the population of lower state is equivalent to N1. The population of higher state is N2. At equilibrium, what is the condition? Number of electrons moving from lower state to higher state. What is the population of lower state? N1. What is the mechanism to send these electrons from lower state to higher state? P12, absorption process. And what is the reverse? The at equilibrium number of electrons moving from lower state to higher state must be equivalent to higher state to lower state. What is the population of higher state? N2. What is the mechanism of de-excitation? Here two options are there, P21 spontaneous plus P21 stimulate. Only one mechanism is there for sending the electrons from lower state to higher state, and whereas there are two mechanisms which is going to make the electrons from higher state to lower state. So this is our equation 4. Let us substitute equation 1, equation 2, equation 3 in equation 4. So that what happens? N1, what is here? P12. What is the value of P12? P12 is equal to B12 into U of mu. So let us substitute that. Instead of P12, B12 into U of mu is equal to N2 into P21 spontaneous. What is the value of P21 spontaneous? A21. Okay, A21 plus this other parameter we have P21 stimulated. The value of P21 stimulated is B21 into U of B21 into U of, right? So further we can write this as N1 B12 into U of mu is equal to N2 A21 plus N2 B21 into U of mu. Let me bring this other side. N1 B12 U of mu minus N2 B21 into U of mu is equal to N2 A21. Let me take U of mu common. U of mu into N1 B12 minus N2 B21 is equal to N2 A21. Or else U of mu is equal to N2 A21 by N1 B12 minus N2 B21. For simplification, let us divide the numerator and denominator with N2 B21. So what happens? U of mu is equal to N2 A21 by N2 B21 by N1 B12 by N2 B21 minus N2 B21 by N2 B21. This is 1, N2 N2 cancel, so what is left out? A21 by B21 by N1 by N2 into B12 by B21 minus 1. So let us substitute N2 by N1 by N2 value. We want N1 by N2 value. So from Boltzmann's expression, N is equal to the population of a given state is equal to population of ground state into exponential of minus E by kT. So N1 corresponding to which state? E1 energy state. So N1 is equal to N naught into exponential of minus E1 by kT divided by N2 is equal to N naught into exponential of minus E2 by kT. Naught and naught cancel. So N1 by N2 is equal to exponential of. So when we bring it to the numerator into exponential of minus E1 by kT. Or N1 by N2 is equal to exponential of E2 minus E1 by kT. But we know E2 minus E1 is equal to h nu. So the value of N1 by N2 is equal to exponential of h nu by kT. So N1 by N2 is equal to exponential of h nu by kT. So let me substitute this value of N1 by N2 here. N1 by N2. Okay. So what happens? U of nu is equal to A21 by B21 into what is the N1 by N2 value? Exponential of h nu by kT into B12 by B21 minus 1. This is our equation 5. Let us compare this equation 5 with Planck's black body radiation formula. Because Planck is also talking about number of photons absorbed per unit area or emitted per unit area. So that what it says, U of nu is equal to 8 pi h nu cube by c cube by exponential of h nu by kT minus 1. This is our equation 6. As LHS side is equal, comparing the coefficients of RHS side, what happens? A21 by B21 is equal to 8 by h nu cube by c cube. B12 by B21 is equal to 1. So what we can write is A21 by B21 is equal to 8 by h nu cube by c cube. Here 8 is a constant, pi is a constant, h is a constant, velocity of light is a constant. So that A21 by B21 is proportional to cube of the frequency, and second one B12 by B21 is equal to 1, which implies B12 is equal to B21. So these two things are called Einstein's relations. What they are saying? The ratio of Einstein coefficient of spontaneous emission to stimulated emission is proportional to cube of the frequency. Einstein coefficient of absorption is exactly equivalent to stimulated emission. So let us stop this session here.